Surpassing the $200 billion USD mark in 2025, the processed fruit industry has officially entered the group of the world's most valuable food sectors. From jams and dried fruits to IQF frozen products, this field is gradually breaking the long-standing dominance of industrial snacks and traditional confectionery in the convenience food market. So how are more than 900 million tons of fresh fruit, highly perishable and closely tied to seasonality, processed into snack products that can be stored year-round? In today's video, join Agriculture Insight as we explore the entire journey that transforms fruit-producing regions across continents, with massive output and extremely high loss risks, into a top-tier food processing industry, where modern farming practices and advanced processing technologies are reshaping how people produce, preserve, and consume fruit. Everything will be revealed right now. Let us begin the journey with the first stop in California, the hub that accounts for up to 90% of U.S. strawberry production, thanks to a unique convergence of coastal loam soils and Pacific Ocean fog. All operations here run like a precision-driven system, especially during the peak harvest season from April to June. Harvesting starts before dawn to take advantage of the lowest thermal conditions, allowing cellular tissue to achieve maximum stability and withstand physical handling without bruising. Unlike fresh market produce, strawberries destined for jam processing are harvested precisely at 80% ripeness to capture peak levels of natural pectin, the gelling agent that creates elasticity without the need for additives. Despite the massive scale, hand harvesting remains a mandatory standard to protect the highly sensitive skin, just 0.1 millimeters thick, equivalent to a human hair, yet responsible for bearing the full stress of deep processing. Instead of applying direct pulling force that can tear the tissue, farmers use a technique of sharply pinching the stem with their fingernails, leaving an exact 1 centimeter segment intact. This action establishes a biological barrier that shields the fruit core from bacteria and prevents premature internal oxidation. With yields reaching 40 tons per acre, California has become a strategic supply source for the global processing industry. To lock in quality, a critical 60-minute golden window begins the moment the fruit leaves the plant. Otherwise, strawberries enter self-respiratory breakdown, causing the loss of valuable sugars and aromas before they ever reach the factory. At the factory, strawberries arriving from the fields enter a rigorous industrial purification process. As the first step, all strawberries are thoroughly washed using recirculated cold water, combined with air bubbling and low-pressure spraying to remove soil and surface residues without damaging the fruit tissue. Once the washing process is complete, the strawberries are transferred to an automated stem and leaf removal system, using optical positioning combined with precision cutting blades to eliminate the green parts without damaging the fruit tissue. This step ensures uniform, fully cleaned input material free from plant debris. When only the intact red flesh remains, the strawberries are fed into cutting and primary crushing machines. Depending on the product line, the mixture may retain large fruit pieces for chunky jam, or be fully pureed to create a smooth, spreadable texture. The next step, and the most critical transformation stage, is heating and concentration. The strawberry mixture, retaining pieces or fully pureed, is cooked in vacuum kettles or indirect heated vessels at around 65 degrees Celsius under low pressure. This process activates natural pectin, removes up to 40% of free water while preserving red color and aroma, creating the characteristic thickness of strawberry jam. Next, sugar and organic acids, primarily citric acid, are precisely added to balance sweetness, gel structure, and microbial safety. The mixture is adjusted to optimal Brix levels and pH, allowing natural pectin to form stable bonds and create a uniform, non-separating gel structure. Through this standardization process, the jam can be preserved for up to 24 months, while fresh strawberries maintain quality for only a few days after harvest. At the same time, air bubbles are removed to prevent oxidation and separation. A slow stirring system ensures a smooth, uniform jam structure. After approximately 30 to 45 minutes of cooking, the finished jam is carefully cooled to around 75 to 80 degrees Celsius before entering the jar filling stage. On the automated production line, glass jars that have been cleaned are fed into the volumetric filling system, where the jam is filled while still hot, with precise volume control and minimal deviation, ensuring uniformity across products. Immediately afterward, metal lids are sealed instantly, creating a natural vacuum environment as the jam gradually cools. The combination of hot filling, vacuum sealing, and high sugar content allows the jam to be stably preserved for up to 24 months without the use of chemical preservatives. After sealing, the jam jars undergo final sterilization before entering the automated labeling line. In the final stage, the products are grouped into standard packs, ready for market distribution. At the next stop, let us head to the Aegean region of Turkey, the center of the global dried fig industry. From fig trees thousands of years old, the country controls up to 60% of the world's dried fig market, with export values reaching $250 million per year. In the Aegean region, where summer temperatures frequently exceed 40 degrees Celsius and dry Mediterranean winds blow continuously, Sarlap figs, the leading golden fig variety in the global dried fig industry, self-concentrate directly on the tree. Water evaporates slowly while sugars are retained within the fruit tissue, creating a stable, chewy texture and authentic flavor, an advantage that artificial heat drying struggles to replicate due to excessively rapid moisture removal. However, this very mechanism of natural dehydration creates the greatest harvesting challenge: asynchronous ripening. On the same branch, each fig reaches a different level of dryness from day to day, forcing more than 30,000 farming households in Aden to remain constantly present in their orchards throughout the harvest season. Harvesters use long poles to gently tap the branches. Only figs that have reached the standard dryness threshold naturally detach from the stem and fall onto nets, while fruits that are still moist remain on the tree to complete the concentration process. This method not only protects the thin, easily damaged skin, but also acts as an on-site moisture control step, reducing early risks of mold and microbial growth from the moment of harvest. Building on this level of control, the crucial drying stage is carried out based on the principle of natural convection, rather than cold drying technologies used by Americans for the Mission black fig variety. The figs are spread evenly on raised wooden racks for 3 to 5 days, allowing bidirectional airflow to remove moisture uniformly from the core to the skin. Once moisture levels fall to a safe threshold, the concentrated sugar content becomes sufficient to naturally inhibit microbial growth, enabling the figs to maintain stable quality for up to 12 months without the use of chemical preservatives. To meet export standards, the figs are sent directly to processing facilities for cleaning and standardization. The process begins with mechanical screening on vibrating conveyor belts, where broken figs, foreign materials, and undersized fruits are removed, leaving only uniform and intact figs to proceed to subsequent processing stages. After being cleaned and dried, the figs are hand-sorted by skilled workers. Only the finest fruits earn the tender and juicy label, certifying a soft skin, syrupy interior, and an ideal moisture level of around 24%, delivering a naturally concentrated sweetness. Finally, qualified figs are fed into vibrating hoppers and automatic weighing systems before packaging, helping preserve their soft, juicy structure and limit moisture reabsorption or oxidation throughout transportation. Highbush blueberries, accounting for up to 80% of global production, have become the star of the industry thanks to their ability to ripen uniformly, enabling large-scale mechanized harvesting. Every June, Oxbow steel giants begin their deployment across farms stretching from Oregon to Washington, USA. Their distinctive arched frame design allows the machines to envelop entire rows of bushes, moving through dense canopies without the need for cleared pathways. At the heart of the system is a dual-axis shaking unit capable of interpreting ripeness. By precisely adjusting vibration frequencies, the machine detaches only berries that have reached optimal sugar levels, leaving unripe fruit untouched. With a capacity of up to 400 kg per bin, this technology enables large-scale farms to operate 24/7, sustaining outputs of tens of tons per day. The first step in the process, and also the critical stage that determines the quality of frozen blueberries, is washing. Upon entering the plant, the blueberries are passed through a recirculated cold water washing system, combined with air bubbling and gentle water flow to remove dirt, dry leaves, and residual debris from mechanical harvesting. The entire operation is designed to minimize impact on the fruit surface, as blueberry skins are very thin and prone to cracking under high pressure. After being washed with purified water, all blueberries enter the optical sorting stage. Here, multispectral cameras scan each berry in 360 degrees, analyzing color, shape, and surface damage in real time. Any berries that fail to meet color standards or show bruising or tissue cracking are immediately removed by high-speed air jets without mechanical contact. Only berries that are round, plump, and highly uniform are retained as qualified raw material, ensuring consistency in quality, structure, and sensory characteristics from the very first control stage. Once the sorting process is complete, all blueberries are transferred to the heart of the plant, the individual quick freezing (IQF) system. The key to a frozen blueberry retaining its original character after thawing lies in freezing speed. Instead of conventional slow freezing, which can cause clumping and juice leakage, blueberries are passed through a freezing chamber with temperatures dropping to -40 degrees Celsius. In this environment, each berry is kept suspended by powerful streams of cold air, allowing it to freeze almost instantly and remain completely separate. This process not only locks in the fruit's cellular structure, but also freezes in the full content of anthocyanins, responsible for the deep purple color, and vitamins, the valuable antioxidants that define blueberries as a superfood. For most American children, raisins are seen as the most disappointing chocolate imposter on Halloween night. Yet behind this humble snack, a billion-dollar industry is operating at full force in California's San Joaquin Valley, producing up to 95% of the United States raisin output and accounting for 1/3 of global supply. To meet this massive demand, the OVD, dry-on-vine method, was developed and quickly became the most widely adopted standard in modern raisin production. Grapes are planted in straight rows with spacing and canopy height standardized for mechanized harvesting, supported by open trellis systems that allow grape clusters to hang freely and achieve optimal exposure to air circulation and sunlight. When the grapes reach physiological maturity, with high sugar content, approximately 20 to 24 degrees Brix, farmers cut the nutrient-supplying stem. From that moment on, the grape clusters no longer receive water or nutrients and begin to dry gradually on the vine, transforming the ripening process into a controlled natural drying process. After approximately 6 to 8 weeks, an entire vineyard that was once full of fresh grapes is transformed into rows of dried grape clusters hanging across the trellis, uniform in both moisture level and sugar concentration. That is also when specialized shaking harvesters, the familiar giants of California's raisin vineyards, enter the fields to carry out the final stage. The machines move slowly along the grape rows, using a system of flexible shaking rods that act precisely on the trunk and canes, strong enough to detach the fruit without damaging the vine structure. The dried grapes fall onto collection trays, are carried by conveyor belts into storage bins, while leaves and light debris are removed directly on the machine. Once the harvest is complete, all dried grapes are transported to the factory within just a few hours. Time at this stage is a critical factor, determining quality stability, the ability to control microbial activity, and the final commercial value of the product. After leaving the fields, raisins are received at processing plants and quickly fed into the processing line. In the first step, the raisins are poured onto vibrating conveyors and destemming drums, where dry stems and leaves are separated, while stones, soil, and large foreign materials left from mechanical harvesting are removed. Next comes the most critical stage, dry cleaning. The raisins pass through rotating drums, soft brushes, and high-pressure air-blowing systems, which thoroughly remove fine dust and surface contaminants without using water, preventing the risk of moisture reabsorption and loss of storage stability. Some plants may wash the raisins using low-pressure spray nozzles for a very short duration after dry cleaning. Immediately afterward, the raisins are dried instantly using hot air or forced airflow to prevent water uptake and microbial activation. In the next step, the raisins undergo optical sorting using color cameras and sensors, automatically removing moldy, sunburned, overly dry, or discolored berries, ensuring uniform sensory quality. Finally, the qualified raisins are weighed and packaged for retail, or packed in bulk containers depending on the intended use and export market. Imagine standing beneath a persimmon tree in autumn, where vibrant orange fruits sway gently in the soft sunlight. Welcome to Japan, the capital of wind-dried persimmons, where over 16,000 tons of dried persimmons are produced each year using a blend of traditional craftsmanship and modern technology. Here, wind-dried persimmons are more than just a delicacy. They are a cultural symbol, a refined winter gift cherished in every household and ceremony. A surprising fact, the white frost coating on the persimmon isn't mold. It's actually crystallized natural glucose, formed as the fruit dries. This sugary bloom is a mark of quality. The whiter it is, the sweeter and rarer the fruit, and the higher its value. Though sweet and delightful, persimmons can become a natural enemy of milk, especially when eaten on an empty stomach or by those with sensitive digestion. This combination can lead to indigestion, and in some cases even form intestinal blockages if consumed carelessly. From a beloved autumn treat to a real-life forbidden fruit, persimmons are both delicious and deserving of proper understanding. Every October, as the first chilly winds of the season arrive, persimmon orchards begin to glow with vibrant shades of orange and red, signaling the official start of the harvest season. At this time, the fruits grow larger and heavier, weighing down the twisted, brittle branches and prompting farmers to enter the busiest period of the year. To prevent the ripe persimmons from falling prematurely, farmers often set up bamboo poles or wooden supports beneath the canopy, tying the branches with ropes to keep the trees from breaking under strong winds. To harvest the fruit, farmers typically use specialized pruning shears, regardless of whether the persimmons grow low or high on the tree. Even for fruits within arm's reach, they still use the shears to carefully cut the stems, preserving the intact stem and avoiding scratches on the delicate skin. For clusters hanging high in the canopy, the task requires even greater precision. The picker extends the shears up to 3 to 6 meters, aligns them carefully, and makes a clean cut. Afterwards, all the harvested persimmons are gently placed into padded baskets to prevent bruising or surface damage. With towering persimmon trees that are several decades old, the harvest becomes significantly more challenging. Clusters of fruit hanging 6 to 7 meters high require farmers to climb trees or use ladders, skillfully maneuvering long-handled shears to reach each one. Every movement must be precise, both to ensure the picker's safety and to avoid scratching the fruit, as even a small bruise can ruin an entire batch of wind-dried persimmons later on. Once harvested, the plump, ripe persimmons are neatly arranged onto transport carts, ready to begin the next stage of their journey. The first stop for the freshly harvested persimmons is the wind-dried persimmon processing facility, where their transformation begins, from rough, raw fruit into chewy, sweet delicacies sought after around the world. Not all persimmons are suitable for drying. Only the large, astringent varieties with firm skins and high tannin content can endure weeks of hanging without falling apart. That's why the final sorting process at the facility is carried out with utmost care and precision. Freshly harvested persimmons are highly susceptible to softening, spoilage, or early fermentation if exposed to high temperatures or excessive humidity. For this reason, immediately after sorting, the fruits are moved into cold storage rooms, kept at around 1.5 degrees Celsius, just cold enough to preserve their freshness and slow down the natural ripening process. Once ready, each persimmon enters the peeling line, a process that may seem simple, but plays a crucial role in determining the appearance and final quality of the product. First, any excess leaves and small branches around the stem are trimmed off by automated cutters to prepare the fruit for peeling. Each persimmon is then firmly secured on a rotating spindle, while a set of sharp blades glides around its surface in a spiral motion, swiftly and precisely removing the thin outer skin without damaging the tender flesh inside. With a processing capacity of 1,000 to 1,200 fruits per hour, this system boosts productivity by more than 10 times compared to manual peeling, ensuring uniformity and reducing labor demands. However, no matter how fast these steel arms work, they still can't replace the human touch. Before hanging, workers carefully inspect each fruit by hand, trimming away any leftover rough edges that machines may have missed, because even the slightest flaw can compromise the quality of an entire batch. Ever wondered why every part of the persimmon is peeled except for the stem? That stem is far from useless. It's the anchor that allows the fruit to be suspended during the drying process, where the magic of sweetness truly begins. After peeling, each persimmon is carefully tied by its remaining stem and hung on a drying line. Skilled workers use nylon or specialized cords, deftly threading them through the stem and securing each knot to ensure that the fruit hangs 20 to 30 centimeters above the ground, without tilting or touching one another. This spacing is essential for even drying and to prevent mold growth. Depending on the scale of the facility, each line may hold 10 to 20 fruits. In some places, persimmons are hooked individually onto metal racks. In others, they are strung in symmetrical pairs for easier transport and better airflow during the drying process. Though this step may seem simple, it requires great consistency and precision. A single loose knot can cause an entire string, potentially worth thousands of dollars, to fall, damaging or ruining the entire batch. The wind drying process typically lasts between 30 and 60 days, depending on the persimmon variety, humidity, and regional climate. During this time, the fruit doesn't simply dry out, it undergoes a deep internal transformation. At regular intervals, each persimmon must be gently massaged by hand. This helps break down tough internal fibers, accelerates the transition from firm to chewy, and encourages the even distribution of natural sugars. More than just a technical step, this is a way for artisans to communicate with each fruit, shaping its soft texture and deep, mellow sweetness, characteristic of premium dried persimmons. Suspended in a clean, well-ventilated environment away from direct sunlight, the persimmons gradually lose moisture. Their natural sugars concentrate and crystallize on the surface, forming a fine white powder, the hallmark of a perfectly dried batch. As the fruit dehydrates, bitter tannins are broken down, allowing the sweetness to come forward. Through a mild natural fermentation process, the persimmon transforms, from astringent to delicately sweet, from firm to tender, a complete metamorphosis in flavor and texture. After being removed from the drying racks, the persimmons are laid out on a breathable surface to rest. At this stage, each fruit is gently rolled or pressed to redistribute the natural sugars inside. This helps create a uniform, tender texture and encourages the formation of the fine white sugar coating on the surface. Once they reach the ideal level of dryness, the persimmons are carefully arranged in traditional wooden boxes or sterile trays, ready for the final stage, packaging and distribution. If wind-dried persimmons are a slow transformation through air and time, then semi-dried persimmons take a different path. Faster, more controlled, powered by heat and technology. After sorting, the persimmons are peeled, with both the stem and core removed, then passed through a specialized cutting machine. Here, each fruit goes through a star-shaped blade, a unique slicing mold, that quickly divides it into even, bite-sized segments. This method not only shortens the processing time, but also produces uniformly shaped pieces that are easy to pack and perfect for ready-to-eat consumption. Before drying, the slices are neatly arranged on mesh trays to maximize heat circulation and prevent them from sticking together. Dozens of trays are then loaded into industrial drying chambers, where temperature and humidity are precisely controlled, typically kept at 50 degrees Celsius for over 20 hours. No sunlight, no wind, everything is managed by machines to ensure each slice dries evenly, remains soft and chewy, and retains its vibrant orange color. It's the industrial version of wind drying, faster and more compact, yet still requiring precision at every step. After drying, the persimmon slices are manually sorted under standardized lighting to remove any that are curled, undersized, or uneven in color. Only slices that meet strict standards for texture and color are transferred to an automatic weighing conveyor, which accurately portions each batch. The slices are then packed into multi-layer laminated pouches designed to block moisture and light, allowing long-term storage without the need for additives. Before sealing, a small amount of nitrogen gas is injected into each pouch to prevent oxidation and preserve freshness. The pouches are then heat sealed to ensure an airtight and secure closure. Right now, we are in California, known as the avocado capital of the United States. This state produces 90% of the country's total avocado supply, making the U.S. one of the world's largest avocado producers. However, domestic production still doesn't meet demand, forcing the U.S. to import a large amount of avocados from other countries, especially Mexico. Typically, an avocado tree takes about 6 to 7 months to bloom and bear fruit. By summer, when the orchards are heavy with ripe avocados, farmers work tirelessly, checking ripeness, preparing harvest baskets, and carefully hand-picking each avocado to ensure the best quality. The United States is known for having one of the most advanced agricultural industries in the world, where high-speed harvesting machines and cutting-edge technology help boost productivity. However, when it comes to avocados, no machine can replace the hands of a skilled farmer. To ensure the highest quality, farmers still rely on traditional hand harvesting methods, paying attention to every little detail. They only pick perfectly ripe avocados, not too soft, not too firm, with smooth, unblemished skin. Long poles with specialized cutting blades allow them to reach avocados on high branches, while sturdy ladders provide support for picking fruit in harder-to-reach areas. Once an avocado is cut from the tree, it is carefully placed into a basket worn on the chest, preventing any impact that could bruise its delicate skin. Afterward, the avocados are neatly arranged in crates under the trees, ready for the next stage of their journey. A skilled farmer can harvest up to 1,000 pounds of avocados per hour. Compared to machines that can process tons of fruit in the same time, this may seem modest, but the precision and care of human hands are something technology has yet to fully replicate. Hand harvesting not only preserves the quality of avocados by preventing bruising and scratches, but also helps retain their freshest flavor. It's more than just a task, it's an art, reflecting the dedication and respect that American farmers have for their crops. So, what happens to the avocados after they leave the orchard? The answer is about to be revealed. Before reaching consumers, avocados go through a strict processing system at the packing facility to ensure the highest quality. Once they arrive, the avocados are placed in cold storage, where temperatures are maintained between 40 to 55 degrees Fahrenheit. This process slows down ripening, keeping the fruit in its optimal condition before moving on to the next processing steps. The avocados are first carefully transported through an automated conveyor system, guiding them to the washing area where the cleaning process begins. Here, high-pressure spray nozzles operate with precision, releasing powerful streams of clean water onto the surface of each avocado. Layers of dirt, impurities, or any debris clinging to the avocado skins are thoroughly removed thanks to the force and accuracy of the spray system. This process not only ensures the avocados are clean, but also guarantees that they meet strict hygiene standards before proceeding to the next stages of processing. Next, they pass through a water tank containing a food-safe solution, which helps eliminate bacteria and extend their shelf life. After washing, the avocados journey into the drying system, where soft rotating brushes embrace them like a gentle breeze sweeping over rolling hills. They tumble gracefully, shedding every last drop of moisture as if shaking off a light morning dew. This delicate process ensures each avocado emerges pristine and unscathed, its skin smooth and flawless, ready for the next stage of its adventure. Next, the avocados pass through a high-speed optical sorting machine, where state-of-the-art laser sensors scan each fruit in a fraction of a second, analyzing color, size, ripeness, and even the tiniest surface defects. This system operates with remarkable precision, processing thousands of avocados per hour to ensure consistency in quality. By maintaining strict quality standards, this automated sorting process ensures that only the finest avocados continue down the production line, optimizing efficiency while minimizing waste. After passing the quality check, the avocados move along the conveyor belt to the automatic labeling machine. Each label is printed with information about the origin, type, and batch number, then applied directly to the fruit. Finally, the avocados drop onto a lower conveyor belt, sorted according to their size, before moving on to the next stage of processing. Here, workers carefully pick up each avocado, placing them neatly on padded trays before packing them into cartons. Additionally, avocados can also be carefully packaged in durable mesh bags, which allow for proper ventilation and help maintain the freshness of the fruit during transportation and storage. In more advanced factories, automated robotic arms take over this task. These robots are equipped with high-precision sensors, allowing them to pick up each avocado and place it into cartons without damaging the delicate skin. A single robot can package over 1,200 cartons per hour, significantly boosting production efficiency. Once packaged, avocados are stacked onto pallets and moved to cold storage, where they are kept at a temperature of 39 to 42 degrees Fahrenheit. This controlled environment helps maintain freshness and quality before they are transported to consumers. In the US, while 65% of avocados are consumed fresh, the remaining 35% are processed into products such as avocado oil, and most notably guacamole, a creamy, rich dip made from mashed avocados blended with selected spices to create a refreshing and flavorful taste. Once cleaned, the avocados continue along the conveyor belt to the peeling and depitting station. Skilled workers carefully cut the avocados in half, remove the pits, and scoop out the flesh with precision, ensuring the soft, creamy interior remains intact without damage. The avocado flesh is then transferred to the grinding system, where sharp blades blend it to a perfectly smooth consistency. At the same time, lime juice, salt, garlic, onions, cilantro, and green chilies are added using an automated dosing system, ensuring a well-balanced and consistent flavor in every batch of guacamole. Once mixed, the guacamole undergoes a thorough quality check, where its texture, color, and taste are inspected before entering the packaging line. The mixture is then pumped into containers or vacuum-sealed bags using an automated filling system, with an accuracy of just 1 gram, ensuring each product has the correct weight. Guacamole is then placed into the HPP system, a technology that uses extremely high pressure to eliminate bacteria without the need for high temperatures or preservatives. This process helps maintain the fresh flavor and quality of the product for a longer shelf life. Finally, the packaged guacamole is carefully stacked onto pallets and stored in cold storage, ready for distribution to supermarkets, restaurants, and consumers worldwide. Beyond its creamy, flavorful dip, avocados are also processed into high-value, nutrient-rich oil. After being cleaned, peeled, and pitted, the avocado flesh is finely mashed before entering a cold pressing system to extract pure avocado oil while preserving its natural nutrients. The extracted oil then goes through a filtration and refinement process using advanced technology to remove impurities, ensuring the highest level of purity. The final product has a light yellow or greenish color, rich in healthy fats and vitamins for health and beauty. In addition, frozen avocado is highly popular because it provides an effective way to preserve the fruit while maintaining its flavor, color, and nutritional value. The avocado flesh is cut into pieces and quickly frozen at -0.4 degrees or lower to prevent oxidation. Thanks to rapid freezing technology, frozen avocados can be stored for up to 12 months without the need for preservatives. This product is widely used in smoothies, guacamole, avocado sauces, and many other dishes. Did you know that every avocado tree starts from a tiny seed? However, to ensure high yield and quality, farmers typically germinate the seed for 4 to 6 weeks. Afterward, it is grafted with branches from high-quality avocado varieties, ensuring larger, tastier, and more stable fruit. After 6 to 12 months, young avocado trees are transferred to well-drained, loose soil in orchards, with each tree spaced 13 to 20 feet apart to allow for proper growth. Automated drip irrigation systems efficiently supply water, preventing overwatering and root rot. After 3 to 4 years, the trees begin to flower and bear fruit. But to maintain quality, farmers prune the branches annually to ensure better airflow and reduce pests. In Washington, where the apple season runs from August to November, the most critical part of the harvest isn't the picking itself. It's moving 400-kilogram bins out of the orchard as quickly and cleanly as possible. That's why the Krolik bin handling system has become the new standard in high-density orchards. The system's logic is simple but remarkably effective. It uses 2 independent rail levels running along each tree row. When a full bin reaches the transfer point, the upper level moves it out of the row through a designated exit. At the same time, the lower level pushes an empty bin into the exact spot that just opened. The whole exchange takes only seconds. No forklifts, no waiting, no picker forced to pause mid-task. This configuration solves a major bottleneck in modern apple production. Tight row spacing, often just 3 meters, combined with large, continuous acreage stretching for hundreds of hectares. Minimizing machine movement and bin handling also reduces impact on the fruit, helping maintain the crispness and firmness that are easily lost when bins are jolted around. Overall, the system doesn't just speed up transport, it improves fruit quality, a small mechanical insight, but one that reshapes the entire rhythm of the harvest. After leaving the tree rows, the full bins are loaded onto specialized trucks and taken to a collection and pre-processing facility, located about 3 to 5 kilometers from the orchard. This short distance is intentional. It minimizes the time apples spend outside controlled conditions, reducing bruising and preserving firmness before they enter the sorting line. At the facility, each bin is quickly cooled, washed, and quality checked before moving on to cold storage or the packing plant. Keeping this initial transport segment short is a key factor in preserving the fruit's overall quality. In Queensland, home to some of the largest continuous sugarcane fields in the world, cane trains run day and night from June until the end of the year. This rail network stretches more than 4,000 kilometers, linking hundreds of farms to more than a dozen coastal sugar mills. What's interesting is that despite the length of these trains, the locomotives are small and lightweight, specially designed to run on tracks less than 2 feet wide. Each train can haul up to 800 tons of sugarcane, moving steadily through the fields to collect the entire harvest of the region. This system saves fuel, reduces road congestion, and forms the backbone of Australia's sugar industry, one of the few places in the world where agricultural railways still operate at such scale. For the people of Queensland, the sound of a cane train's whistle signals not just a busy harvest season, but the rhythm of an entire economy in motion. In greenhouse farms growing tomatoes, strawberries, or cucumbers, the job of moving produce from the crop rows to the processing area is handled by specialized electric tow tractors. They're small, agile, and able to operate in aisles less than 1 meter wide, spaces where any larger vehicle would be useless. Many farms still use electric tow tractors with drivers, pulling long trains of full harvest crates. But in more advanced greenhouses, you'll see autonomous units that follow magnetic sensors or camera guidance, transporting produce to the packing area automatically. What surprises most people is that an autonomous tractor like this costs between $8,000 and $20,000 USD, depending on the level of automation. It's expensive, but it cuts nearly 70% of manual lifting and carrying, and it shortens transport time, a critical factor in keeping delicate crops like strawberries or tomatoes fresh, firm, and full of flavor. In Ecuador, where more than 30% of the world's exported bananas originate, plantations handle massive daily volumes across challenging terrain. To keep produce moving smoothly between plots that can be a kilometer apart, growers rely on a system few people expect: aerial cableways designed specifically for bananas. These lines are built on steel towers about 3 to 4 meters tall, running straight through the fields without needing any road underneath. Banana bunches are hooked onto trolleys fitted with low-friction bearings, allowing them to glide along the cable with remarkable stability. This setup minimizes vibration, a critical factor in maintaining peel quality before the fruit enters the grading line. On sections with natural elevation drop, the system uses gravity to move the load. On flatter stretches, low-power electric motors provide gentle assistance to keep the pace steady with almost no energy cost. As a result, a single cable line can transport bananas continuously for hours without interruption. A simple piece of engineering, yet one that sustains the entire flow of production across vast tropical plantations. Seen from a distance, cotton fields in the US look as if someone scattered giant marshmallows across the landscape. In reality, they're the work of next-generation harvesters, machines that pick, clean, and compress the cotton into cylindrical modules more than 2 meters long, wrapped tightly in UV-resistant film. They may look fluffy, but each marshmallow weighs up to 2 tons. Once the machine drops a module onto the ground, the transport race begins. Tractors equipped with curved lifting arms scoop up each cotton roll and raise it effortlessly. The arms match the module's rounded shape, so even when driving over soft soil, the module keeps its perfect compression. Crucial, because even a small deformation can cause problems later on the ginning line. The modules are loaded onto specialized trailers, where the operator lines them up in long rows. A single run can carry 8 to 10 of these massive rolls. Their destination is a staging yard a few kilometers from the field. There, hundreds of modules sit in perfectly straight rows, waiting to enter the gin. The bright yellow wrap protects them from rain, dust, and harsh sun, while keeping the fibers inside clean and intact. When harvest season arrives, the rice paddies come alive with activity. Freshly cut rice is loaded onto trucks or small barges and transported straight to the milling facilities, where the husk is removed, the grains are cleaned, and the final white rice is produced. From there, the rice is bagged, inspected, and moved to the port for the next and biggest stage of its journey. It's at the port that the true scale of the rice export industry is revealed. Massive cargo ships, bulk carriers, can hold up to 60,000 tons of rice, nearly 3 million bags, enough to feed a large city for months. When the ship docks, towering cranes lift bundles weighing several tons and lower them into cavernous cargo holds as wide as indoor arenas. On the ground, teams of workers operate non-stop, arranging, securing, and monitoring moisture levels to ensure every bag stays safe throughout the long voyage across the ocean. From the paddies to the open sea, this entire journey shows one thing clearly: rice is not just food, it's an economic ambassador, carefully handled at every step before it leaves Asia for the world. No longer confined to the ground, modern agriculture has truly taken to the skies. For fresh flowers, especially roses, tulips, and other varieties with a shelf life measured in days, air freight is the only profitable way to move them across continents. Each year, more than 1 billion stems are flown into the United States, with demand peaking around Valentine's Day, when roses from the Andes and tulips from Kenya, Ethiopia, or the Netherlands all head for the same destination. Right after harvest, the flowers are pre-chilled, sorted, and packed into ventilated cardboard boxes that preserve moisture while allowing the blooms to breathe naturally during transit. At the airport, the ground crew races against the clock. They wrap each pallet in specialized polyester netting, strong enough to secure around 300 flower boxes per load, then push them into the cavernous cargo holds of freighter aircraft. Throughout the journey, tens of tons of flowers are kept cold by a tightly controlled climate system and temperature sensors. Thanks to the stability, even though air freight costs 5 to 6 times more than sea freight, the loss rate, from wilting, bruising, or stem rot, is dramatically lower. Because of these high-speed flights, within just 48 hours of leaving the greenhouse, vibrant red roses and colorful tulips appear on store shelves across the United States, ready to become Valentine's gifts for millions.